if you are stuck on any part of the empirical and molecular formula worksheet, here are some pointers. The first part is review of finding empirical formulas. To find the empirical formula, we're going to figure out how many moles are in the amount, how many moles of each thing are given in the amount given, and then we're going to take the ratio to find the formula. So this is given in percents. We cannot convert from percent to moles. We convert from mass to moles. So let's assume 100 grams. Then we have 75 grams of carbon and 25 grams of hydrogen. And we need to find how many moles of each we have. So 75 grams of carbon times 1 mole of carbon. If we look at the periodic table, 1 mole of carbon is 12.01 grams. And we have 25 grams of hydrogen times 1 mole of hydrogen, and this is just using our conversion procedure. We want grams to go away. Grams is going to have to be on the bottom. Mole of hydrogen is 1.008 grams. And if we get the calculator to do this, we get, we then put input 75 divided by 12.01 gives us 6.245. Units are moles. And 25 divided by 1.008 gives us 24.80 moles. So this is pretty clearly 4-to-1. We can check. C to H is going to be 6.245 over 6.245 to 24.80 over 6.245, and that's going to be 1 to 24.80, enter, 6.245 divided, I get 3.97. 3.97 is very close to 4. So this formula is CH4. 4 hydrogens for every 1 carbon. That's the empirical formula. The molecule might have more carbons and hydrogens than that. You don't know. All right, let's jump ahead to the empirical formula for molecular formula. So the empirical formula is going to be the smallest whole number ratio that is equal to this. If this is a molecular formula, it represents how many atoms are in a molecule. An empirical formula is just the smallest whole number ratio. So both of these have a common factor. It's 2. So if we divide out the 2, we get NO2. Again, both of these have a common factor. It's 5. If we divide out the 5, we get an empirical formula of CH2. The molecule contains 5 carbons and 10 hydrogens. The empirical formula says the ratio of hydrogen to carbon is 2-to-1. N2F4, common factor of 2, so that gives us NF2. C6H12O2, common factor of 2, so that gives us C3H6O. We divide each of those subscripts by 2. No common factors here. This is the empirical formula. That happens. C9H12, what's the common factor? It is 3. This is a really funny molecule, but it exists. So that gives us C3N4. I think I said HN. Hg2O2, HGO. This is a weird substance. We won't talk more about it. C4H8, that is a molecule. Common factor is 4. Divide out the 4, CH2. C2H3Cl3, there is no common factor. That is the empirical formula. Okay, sometimes the molecular formula is the empirical formula. P4O10, common factor is 2, so that gives us P2O5. C6H12, common factor of 6, this is CH2. Many things have the empirical formula CH2. This is the second one on this list. C3H6O3, each of these has a factor of 3, so we could say CH2O. Okay, so on the second page, you need to find the empirical formula. No, you don't. You need to just figure out the mass of the empirical formula and then find out what is that factor. That same factor that you just took out in the previous exercise, getting the empirical formula from the molecular formula. Now we're going to find that factor so that we can calculate molecular formulas from empirical formulas. So the empirical formula is CH2O. Its molecular mass is 180 grams per mole. Notice there are no decimal places here. We are going to approximate the molar masses to make this go faster. So the what is the mass? We want to find mass of the empirical formula. Is going to be 1 mass of carbon plus 2 masses of hydrogen plus 1 mass of oxygen. And if I'm not mistaken, that's 30. So how many empirical formulas in molecular formula? Well, how many times does 30 go into 180? That's 6. So the factor is 6. C6H12O6. That's our familiar formula for glucose from biology last year. Empirical formula compound is CH2, so that's mass of empirical formula equals 12 for the carbon plus 2 times 1 equals 14. 70 over 14 is 5, I think. So we have C5H10. Okay, here you need to find the empirical formula. Find the mass of the empirical formula and use that to find the molecular formula. This video is going to go over length and not upload if I do any of these, but this is the same procedure that I showed on page 1 of the worksheet, and then just add this additional step. Remember, please show your work.